Well, hello there. This is Mr. Meyer coming at you from the Way Happy Studios in South Livermore, and we are going to discuss piecewise functions. Now, this is going to be fun. So sit back, get your notebook out, right? Put your headphones on and enjoy a little bit of this wonderful time of note taking. Want you to make sure you write stuff down, make sure you realize that you can pause it at any time. You can rewind even if you want to see what's going on or you just didn't quite get it. So take your time, enjoy this. I hope this video is not going to be too long, and we'll see. So with that, let's get started. Now look at these two graphs I have thrown where you actually see three, but look at the top two. Notice they look like they are pieces from other graphs. Like you see how this slanted line right here, that looks like, some y equals mx plus b thing. And then you got this guy right here that appears to be like part of a parabola, some x squared graph. And then you got this line here that's just a nice constant line, like some x equals graph. So how can they all be living on just one graph? Well, that's because they're different pieces from different graphs, and thus we call them piecewise graphs. Now, the thing that you're going to have to do is try to figure out what pieces they are and when are they being used. That's the big kick, right? When are they being used? Look at this other one. Like we have an absolute value graph going right here. So that's definitely an absolute value graph that then all of a sudden has this shooting star graph on it. So again, two different graphs, two different pieces, two different equations. And then when are they being used? Let's look at this one I just did. Notice like right about here, you see that divide of the two graphs. That happens to be when x is 1. So we tell people, hey, if your x's are bigger than 1, I want you to talk about the shooting star graph. When your x's are smaller than 1, I want you to talk about the absolute value graph. And that's what we're going to have to do here today. So we're going to talk about piecewise functions, which means you're going to be a really good grapher. And hopefully we did that in class today, practicing all our different graphs. And now we're going to talk about analyzing them or whatever. So here's something you see really common. This thing little down here, this mixed nuts problem, right? You see this very common. You go to Disneyland, there's a different price for different ages. You go to Starbucks, there's different prices for different sizes, right? Everything has its own little group, and even here with mixed nuts, right? If you read this graph, you can see as you buy more weight, if you buy more pounds of mixed nuts, looks like the price comes down a little bit. The price was, pretty big to start off, and then it got a little, almost $2 cheaper. So that's what these kind of graphs are good for. Look at all these different pieces that are going here. You got a constant, a constant, a constant, but they're three different graphs, and that's what we're interested in. So what do you know about this graph? You kind of sit back and you look and you're like, all right, well, the one thing I know that is if you get 0 to 1.99 pounds of nuts, you're going to pay $8 a pound. Now, why did I stop at 1.99? Because that open circle meant it didn't include it. Once you buy a little bit more, once you get 2 pounds, you only have to pay $6. So good deal, right? Don't buy 1.99 pounds. You're ripping yourself off. You might as well buy 2 pounds. It's going to be cheaper. So if I get 2 pounds all the way up to, it looks like, what, 4 pounds? Now, it looks like I have a little mistake here. Let's extend this circle all the way to there, because there was a little gap between 4 and 5 pounds where you wouldn't pay anything apparently. So a little mistake. So if I get 2 pounds and I go all the way up to 5 pounds, so let's go 4.99 because you're just not quite there yet, you pay $6 a pound. And then if you look at the last part of the graph, it's like, hey, look, if you buy 5 pounds up to ever, right, up to unlimited, you would only pay, was that about $5 a pound? And that's how this graph is read. This graph, this problem is this. It has 3 different graphs in it, which is amazing. And then I can also see, I can read it and I can say, hey, this is how much it costs if you buy this much weight. How fun is that, right? Now that you got a little idea of these weird equations that do 2 different things at 2 different times, let's see if you can read one. All right, so here's my first example. It says evaluate the functions for x is -1 and x is -4. So let's start off with x is -1. If x is -1 and we come cruising up to this equation, notice we have this weird thing that just freaks people out. People like panic. They just see all this writing and they're just like, I don't know what you're doing, and do I have to shade stuff and what? No, that's not at all what this says, right? What this says is I want to use this line whenever your x's are less than 2, and I want to use this parabola whenever your x's are greater than 2. So it's just telling you it's two different graphs and when you should use them. So the right side's kind of just like your key. This is just like telling you when to use which graph. This is just your key. So now look, we're using x is -1. We look up here at the key and we're like, oh, our x is less than -1. I'm sorry, is less than 2. So we should use this because -1 is less than 2. We shouldn't use this one. So when we use it, we plug it in now. We get 2 times -1 plus 1. That's -2 plus 1. That's -1 for your y value. So the point -1, -1 is on the graph. Nice. So let's try it for now for x is 4. So then they're like, all right, we want you to try this one, x is 4 also. So you come cruising up to your key and you're like, all right, my x is bigger than 2, so I want to use this. I do not want to use that. So on this same exact graph, it just has a different equation for this part. I would plug in 4, and I'd get 4 squared minus 4, which is 16 minus 4, which is 12. And the point 4, 12 is also on the graph. But realize it used a different equation. So you can't connect them because it's not a line. You actually have to plot like a million points to see what's going on. Or if you know what the graphs look like, we can talk about that. Like you're like, hey, wait a minute, I know what those graphs look like. What do you think? Nice, right? So that's your intro to piecewise functions. So look at the second one. You can give it a shot if you want. You know, like pause the video for a second. Here, I'll wait a minute. Go ahead and pause. All right. Did you do it? Did you try it on your own? Because that would have been really good. And so if you didn't, you know, here, we'll do it one more time together. But don't be scared to pause it and try it yourself. Hey, if you think you want to get a head start, go ahead. Pause the video. I'm not mad about it. I like it. I like it when you're trying. So look, the first thing I'm going to do is I'm going to try x equals 1. So I'm like, all right, I got x equals 1. So now I go up to the key, and I'm sorry, -1. I go up to the key and it says, hey, look, use the top equation if your x's are less than or equal to 1. Don't use the bottom one then. So we're not going to use that guy right now. X is -1. So I go, all right, that's 2 to the -1. I happen to know that that means 1 over 2 to the first, which happens to be 1/2. And there's my point. -1/2 is on this graph, right? This graph that's split into two equations has some crazy exponential and it has some nice normal line. So very nice to see that this is a graph that has like a crazy exponential and then just a line and with a slope of 5. Got that guy done. Now look, I'm going to go ahead and I'm going to try it when x is 4. So again, I go up to our key, and our key says if your number is bigger than -1, we want you to use the bottom. You're like, okay, I'll use the bottom then. 5x, so that's 5 times 4, and that's 20. So the point 420, oh, stop, is on the graph, right? So you're like, yes, we just figured it out. And you have just decoded a very complex thing. You have just figured out this crazy looking equation that no one ever likes. And it's really not that bad when you realize what it's saying. It's saying use one graph one time, use the other graph the other time, and they tell you where to split it up. Now this is where I get to ask you a question. So relax, answer this question, and I'll see you in a few. Good luck. Great work. I really think you're getting the hang of this. So good job. You've now answered those questions, and now we can move on to the next thing because we're feeling pretty confident about everything, and so we like it. So guess what? If you could plot one point, that means you can plot a bunch of points, which means you could essentially just graph this whole insane function. So look at this new piecewise function we have here, function g, right? Sometimes it's a line, right? That's a line. It's got a slope. It's got a y-intercept. That's a good graph. And sometimes it's a line on a different line when your x's are greater than 0. So we got to plot all these points. Now, we got two ways to do this, folks. We can plot a bunch of points, as many as possible, or we can remember what we've learned through the years, right? So, let's take this top one first. We're like, hey, I know that. That's a line. That's an equation of a line. It looks like this. It's got a slope right here, and it's got a y-intercept right here. So remember how you graph that? You go on the y-axis, you go up to 3, you put a big old dot, and then you do your slope, right? 1/4. That means rise 1 and run to the right 4. 1, 2, 3, 4. And you got yourself your 2 points. And then what you did is you drew hopefully a nice straight line through it. And that's your equation, right? Y equals, 1/4 x plus 3. Now here's the catch. We're not allowed to use that line all the time, right? There's a little catch that says you only use that line if your x's are less than 0. So here's our x is 0, right? So we should only use that line when it's less than 0. We shouldn't be, in other words, using it over here. That's a bad spot. So we don't want to use that part of the line. So this is all you kind of do. You erase that part of the line. Now I can't do that, unfortunately. I guess I could. But I can't erase it, so you do. You got to do it lightly or something. And I should have an open circle. So I guess I'm going to have to clean this up a lot. So I'm going to take that out again one more time, and I'm going to be like, all right, open circle at 3. We would have gone up 1 and over 4, so I'm going to go down 1 and left 4 to get my second dot. And there you go. There's the equation of the line for the left side, or what they told me to restrict it to. Only use that line when the x's are less than 0. And that's what I did. So sweet. You got it? Now let's do the other one. So same thing. We look at this guy. He's also a line. So you're like, all right, that has a slope of -2 and a y-intercept also of 3. So you're like, I'm going to graph it here. I'll do it in blue this time. And so I go up to 3, put a big old dot. His slope is -2, which means down 2 and over 1. And there it is. And I'm going to connect this guy with a nice line. And I'm like, awesome. I like to label them, I know. Y equals -2x plus 3. And there is that line. But again, it has a restriction. Only show me that line when the x's are bigger than 0. So right here, right? When these x's are bigger than 0, I only want to see that blue line. Don't show it to me over here. So you scribble it out. You erase it. You do whatever. Now look, we're going to have a filled in circle at 0, so I can leave that filled in circle. And I can go ahead and just draw the line, and boom. There's the graph that represents this function. Crazy, right? It's 2 different equations at 2 different times, and it shows you when those times are. It says, hey, look, if x is less than 0, use the top line. If x is greater than 0, use the bottom line. And you're like, piece of cake. And now people are impressed everywhere you go. All right, let's try it one more time. Look at that mess. Like, who does that? Who gives you 3 equations? I do, right? So yeah, let's try it. So here we go. First thing I'm going to look at is this first equation. I see a parabola sitting here, and oh my gosh, thank goodness we have talked so much about shifting graphs. I know it's a parabola. I know it's down 3 units. So if I just go down 3 units, and then a parabola, you go up 1 on each side, and you make yourself this gorgeous parabola. You could plot a few more points to make it pretty, and I don't think that would be a bad thing. But there it is, right? Now wait, we're not supposed to show the whole parabola. We're only supposed to show that parabola if your x's are less than 0. So here's x is 0, this line straight up and down. And I'm only supposed to show it to you on the left side of the line. I'm not supposed to show it on the right. So piece of cake, I'll just erase it. And there you go. You see my parabola there. Now, less than 0, so I can't include 0. So that point I got to take away, and I'm going to put an open circle. And there it is. Beautifully done. Parabola finished. Right? All right, let's move to the next one. You got this beautiful line right here. You got a line who has a y-intercept of -3. So I'm going to y-intercept to -3. He's got a slope of 1/2, which means he goes up 1 over 2. And you can do that, more than once if you want. You want to see how that line looks. You're like, sweet. So here comes my line. Dun, 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 dun. Beautiful. So there is my beautiful blue line, right? And that blue line, oh wait, has a restriction. It's only supposed to be shown from 0 to 4. In other words, here's 0 and here's 4. We're only supposed to show the line in between those two yellow bars. Well, okay. Not a big deal, right? I'll just erase this for a second, and I will make this an open circle because apparently I had to go to 4, and I will just connect this only between what would have been my two yellow lines if I didn't erase them. And there you go. I've shown the line from that little chunk. And then last but not least, we have this guy. Oh, another parabola, right? Ooh, but look at that. We know where the vertex is. I know it's a different form of a parabola. I know that his vertex is at, now remember how to read the shifts? Right 4 and down 1. So that's where his vertex is. So we got to go right 4, down 1. Oh, look at that. Now these won't always touch. This is just, we're trying to show you stuff, so it's cool. And you have a parabola. You'd go up 1 on both sides unless you have a stretch or something. And then you'd be like, yeah, there it is. Oh, but wait. There's that restriction again. Only show this parabola to me if the x's are greater than 4. Well, here's greater than 4. Here's 4. Greater than is everybody to the right. So, yuck, don't show me this piece, right? So you just take that off of the parabola, the green parabola. So I'll erase it. I'll get rid of that point. I'll get rid of all this. And there is your awesome graph. And you are doing piecewise functions. You're reading them. You're knowing when to use which equation. And now you're knowing how to graph all the different chunks. Amazing. Keep up the good work. Let me give you another question, and we'll practice these in class tomorrow. Stay happy.